The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so I'm going to work on problem number 6 for Physics 2020 Midterm Exam 2, year 2006. And this problem asks us, suppose the mass of the Earth and the mass of the Moon were doubled their present values, and the distance between them tripled. By what factor would the force of gravity between them change? Alright, and so basically, if you go on your review sheet, formula sheet, and you look on the third page, you should see an equation for gravitational force. Okay, and so gravitational force we denote as Fg is equal to a gravitational constant times the mass of the first body times the mass of the second body divided by the distance between the two bodies squared. So that's what this. So this is how you calculate the gravitational force between two bodies. All right, and we know that G is equal to 6.67 times 10 to the minus 11 newtons meter squared per kilogram squared. Alright, and in this problem we're asked to find by what factor would the force of the gravity between them change if we basically doubled the mass of the Moon and the Earth and we tripled the distance between them. Okay, so let's say that we have the gravitational force between them initially, right? You'll have the gravitational force times the mass of the Earth initially times the mass of the Moon initially divided by the distance initially from them squared. Okay? And so we know that if we double the mass of the Moon and the mass of the Earth, that means that that the mass of the Earth, the final mass of the Earth, is equal to 2 times the initial mass of the Earth, because we're just going to double the Earth, double the mass of the Earth. And we know that the mass of the Moon, final, is equal to 2 times the mass of the Moon, initial. Okay? And we know that the final distance between them is going to be 3 times the initial distance. Alright, and given these relationships, we can find the final gravitational force between them. So the final gravitational force between them is going to be the gravitational force, which is constant, times 2 times the mass of the initial Earth times 2 times the mass of the Moon's mass divided by 3 times the initial distance squared. Alright? And we can simplify this expression. We know that if we just pull out the constants here, we know that the numerator will get 4, and we'll get G times mass of the Earth initial times mass of the Moon initial divided by squared, which is just 9, times Ri squared. And if you look at this part of the equation, that's the same as this part of the equation. Alright? And so the final gravitational force is just going to be a factor of 4 over 9 of the initial gravitational force. Alright? So the answer is the factor is going to equal to 4 over 9. And just as a side note, 4 over 9 is going to be less than 1, so the gravitational force is actually going to be less. Okay, so this is the solution to the problem.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.